Welcome to Summarize Science. Imagine a robot that's completely soft and squishy, like an octopus. Scientists have been trying to build them for years, but one big problem has always stood in their way. How do you give a soft robot a brain? Traditional computer chips are hard, rigid, and fragile, the exact opposite of what you want in a soft robot. But what if the robot's body was its brain? This incredible paper explores a concept called physical computing to create intelligent soft robots without any traditional electronics. So, what is physical computing? Instead of using electricity flowing through silicon chips, it uses physical things like movement, pressure, and vibrations to process information. The researchers in this paper explain that the robot's body acts as a kernel, taking in information from the environment and physically processing it to produce an output. They break it down into two main types, analog and algorithmic. Let's start with analog, which is all about continuous signals. Check out this amazing little robot. It walks and coordinates all four of its legs using nothing but pressurized air. A clever device called a ring oscillator creates a rhythmic pulse of air that acts like a heartbeat, telling the legs when to move in a coordinated pattern. It's a walking gait generator with zero electronics involved. Another fascinating analog approach is called physical reservoir computing. Look at this soft robotic arm. It can actually figure out what kind of object it's holding, not by seeing it, but by wobbling it and analyzing its own physical vibrations. The complex dynamics of the soft body itself act as a powerful computer, sorting through the vibration patterns to extract useful information. This allows the robot to sense its world in a profoundly new way, using its entire body. The other side of physical computing is algorithmic, which is more like a traditional computer that uses discrete on-off signals. But instead of electricity, these systems use things like fluid. This robotic hand is controlled by a fluidic logic circuit. Tiny channels and valves direct the flow of air, acting like soft transistors that can perform logical operations like and, or, and not. This allows the robot to make decisions and switch between different actions, all by controlling the flow of air. So, let's recap the incredible ideas from this paper. Researchers are developing ways to make soft robots intelligent by embedding computation directly into their bodies. They can use physical oscillators to generate movement, the body's own complex dynamics to act as a sensor, and fluidic circuits to make decisions. What does this mean for the future? It opens the door to entirely soft, autonomous robots that are safer for humans, more resilient in harsh environments, and could even operate inside the human body for medical procedures. This is a huge step towards creating truly lifelike and intelligent machines. Thanks for joining us on Summarize Science.